Okay, Amar, tell me about black holes.
Black holes. Okay. Right, a black hole is created when any object, any piece of mass, exceeds critical mass, which is when its gravity is greater than the outward force pushing on it. So if you've got, it doesn't matter what it is. This is the thing. It doesn't matter what this thing is.
An Oreo.
It's got, yes, that's going to be an Oreo. The Oreo has obviously outward forces pushing out. Like if I grab your hand,
oh,
the part would push back against my hand so I don't crush into it.
Right.
If the gravitational pull is greater,
right.
then the forces that push back out again will collapse in on itself.
Okay.
And become real small.
So the Oreo gets smaller?
The Oreo gets smaller, but its mass stays the same.
So its weight, is that the same?
Weight is when mass is times by gravity.
Oh, gosh.
Mass is the same regardless. So if you went, I weigh 85 kilograms. If I went to the moon, I'd weigh like 70.
Oh, I know what you mean. You explained this to me the other day. Carry on.
Okay, what I'm going to be talking about is stellar black holes, which is created when a massive star collapses on itself because it runs out of fuel.
Right.
Basically, the star has to be, our sun is way too small for it to happen. Basically, what will happen, in a star, throughout its life, it will create light and such.
Yes.
That's
not a star, Amar. It's an Oreo.
Yeah, it's not. That all goes outwards. Okay, the way it does this is by nuclear fusion, which is where you get two molecules. It uses hydrogen in our sun and most things. So you've got hydrogen plus another hydrogen. This can be a H2 molecule. They fuse together and create helium.
So why is, if hydrogen is the same, why is it H1 and H2?
Because they can join in different ways.
Okay.
This is just
equals helium.
So that goes into helium and it forces them together. So it forces the atoms together, the nucleus, to create a bigger nucleus, heavier element. It does this, and as it does that, it gives off loads of energy, and all this comes shooting out, and that pushes outwards to stop the gravitational force crushing it all inwards.
Right.
So that's happening while it's alive. Then, when it runs out of energy, it runs out of fuel, that stops. So there's nothing to stop the huge gravitational pull from pushing it all in. So there's nothing, because all this fuel is gone, there's nothing anymore pushing out, it's all pushing inwards. Or pulling inwards with the gravity.
So it gets smaller.
The middle collapses. So it goes from here, pushing out. This middle goes from here to this big. So collapses in on itself in the middle. Now when it does that, its mass stays the same, but because there's nothing pulling outwards, it pulls everything else in.
Yeah.
It does this so quickly that there's loads of friction causing heat, there's electromagnetism going everywhere, everything...
What? Say it again?
Electromagnetism is going wild, everything goes mental, pulls everything in, and then it explodes in a supernova, which is something... A supernova is an event which outshines a galaxy. It's so bright, it gives off more energy than our sun will give off in its entire lifetime.
Okay.
In a very short space of time. It just explodes.
Can I ask a question? So does this happen, like, regularly?
Yeah.
And do we see it?
Yeah,
from
Earth? Telescopes and stuff.
Okay.
So
you said it gives off more light than the sun?
The sun will give off over its entire lifetime more energy.
So it must be really, really bright.
Yeah, it outshines the galaxy.
Can you see it if it happens during the day, or can you only see it at night?
I'm assuming during the day also.
That was a good question, wasn't it?
That was a good question.
Yeah.
So yeah, it explodes in the supernova and shoots energy everywhere. And what's left is a black hole, which is a little piece of mass. Well, not a piece of mass, like a very massive amount of stuff in a very small space that pulls in anything that gets trapped in its gravitational pull. There's an area, we'll call this, that's the black hole. This is called the event horizon. Right. Anything that goes past this point
gets sucked in.
Gets sucked in and cannot come out. Nothing can escape. Light, heat, anything will get sucked straight in if it goes past this event horizon into the middle, which is called the singularity, which is the middle part.
Okay.
That will suck everything in.
And then where does it go?
It will be absorbed into the mass.
Does it then get bigger and bigger because it's sucking more stuff in?
It gets more massive. It gains more mass.
More massive. Oh.
Anything that goes in, I read this earlier on, it gets what's known as spaghettified. Because there's such strong gravitational ties and everything, it just gets ripped to pieces and split over everything. Anything that goes in there, we know...
That was a terrible laugh, I apologise.
Okay, anything that goes in, we don't know what happens to it because we can't see it because the light goes in and doesn't come out again.
So will the black hole keep getting bigger and bigger and bigger and eventually suck everything up? Is that what will happen?
Technically, yes.
Wow.
But it's not likely things won't go near it.
Not anytime soon. Are there loads of little black holes?
There are things called...
What happens if a black hole sucks up a black hole?
They become a supermassive black hole.
What? like the song?
I like that song, yes.
Brilliant.
Yeah, so a black hole is that which I've said.
Brilliant. Thanks, Amar.
You're very welcome.
Can't turn it off.